Well, let's just go and check some more questions because some more examples because some student here say, Hamish, we just want more example. Those examples not enough. Okay, let's go and check some more. Let's go and check some more. Excuse me, Okay, let's go. Some more example right there. You ready? Let's go. So I got some more example here. So let's take example on the root rules. Imagine. So we know, like I said before in the previous video, if you have a b square minus 4ac when it's greater than 0, and then we get 2 and unequal real roots. Unequal real roots. So let's say example, good example of this. But if b square minus 4ac, if it's greater than 0, if it's less than 0, then we get 2 unequal to unequal imaginary rows, to unequal imaginary rows, and then if b square minus 4ac is equal to 0, and then we get 2 equal real rows. Okay, Hamish, I understand previous example, but can you explain more example? Yes, let's say example here. Somebody give us, for example, this quadratic here, and we'll use mostly for quadratic. Minus 2x plus 1 equal to 0. So let's test and see. So how are we going to test? We test by using b for ac. We want to see if it's going to be greater than 0 or equal to 0, or it's going to be less than 0. It's plug. So b, what is a b? Our b, this number here. So negative 2. 4 times a, what is it? A equal to 1, and c is equal to 1. So plug it in, it's going to be 4 times, and it's going to be equal to 4. What is 4 times 4? 4 minus 4 equal to 0. So it falls under here. Under it. Let's just go. And you see that? It falls under here. Under here. So what that means? So we get 2 equal real roots. So we're going to say, okay, so for that case, if b squared minus 4ac became equal to 0, means it falls under here. So we're going to say, so what happened? Means it's 2 equal real roots. That's all. What do you mean, Hamish? Okay, so that's your answer. You got your answer ready. So let me just prove to you. We're gonna have to prove this, right? So that you understand what's happening. But you're done with your answer. If they ask you an example. So let's prove what I mean. Excuse me. So the question say, 1 is just x squared minus 2x, and everybody see that. I hope everybody can see. Plus 1 equal to 0. So we know whenever somebody gives us this, we're gonna have to plug in the quadratic equation. I made a question of quadratic which equal to negative b, and the plus or minus square root. Excuse me. Square root. Let's see how about to make a pen. This make a pen and get finished. Square root b square minus 4ac. Sorry about that. My other pen just get finished, and then over 2a. So we say x equal to negative. What is a b? Equal to negative 2, and then plus or minus, and then square root. What is negative 2 square minus 4 times a? What is a? A equal to 1. This is a here. A equal to 1, and c is equal to 1. So plug it in. 2 times a equal to 1. So we only focus here, right here. So what we see there, we say x equal to positive 2 plus or minus. When you put in the calculator, or just look, negative 2 squared 4. Let me just go slowly. So say, oh, Hamish, you went too fast there. Okay, it's going to be 4. So what we're going to get here, 0. So you see this meaning is b squared minus 4ac. It gave us this one, 4 minus 4, which equal to 0. So we see b squared minus 4ac. What happened? Equal to 0. So we're going to say, okay, over 2. So x equal to plus 2 plus or minus 0 square root, which is 2. So x equal to plus 2 plus or minus 0 over 2. So now we say finally x equal to positive 2 plus 0 equal to positive 2, or x equal to positive 2 minus 0 equal to positive 2 over 2 over 2. So x equal to positive 1, or x equal to positive 1. So what did you see? We get two roots, and they're equal. And that's how the definition say. Whenever you have a b squared minus 4ac, when it's equal to 0, we get 2 equal roots. How to say, Hamish? We say it again. We say, oh, we know when b square minus 4ac, when it's equal to 0, you see here we go 0 here, 4 minus 4 equal to 0. But what this means, this is 4, you see, this one here, plug it in, it gives us what? 0. So when it gives us 0, we see, oh, our roots become what? 2 equal real, you can see these are real, not imaginary, 2 equal real roots. That's what we say whenever b square, whenever this b square, the one under the roots, whenever this, when it's equal to 0, like when you plug it in, it gives us equal to 0, and then you get 2 equal, you can see x equal to 1, x equal to 1, real roots. Let's take other example. Okay, shows me somebody give us 2x squared plus 8x minus 1 equal to 0. How you solve it, Mr. Hamish? Sometimes other people call me Jitum Quali, right? On my music, I don't use Hamish, I use Jitum Quali. You know what I'm saying? Mntwana Wa Bantu is my academy. Mntwana Wa Bantu Academy. On my music is Jitum Quali. So let's go Jitum Quali. Let's go. So let's solve this one. So it's okay. Let's take space to b squared minus 4ac. We wanna see. Okay, excuse me. Let's take something out here. So we say let's plug it in. What is our b equal to positive 80? But we square minus 4 times a equal to 2 times c. What is a c? C equal to negative 1. This is c and this is b. So let's see what we're gonna get here. So this is gonna be 64 minus 8. 8 times negative is gonna be, excuse me, 2 times 4, 8. 8 times negative 1, negative 8 times negative is gonna be positive 8. But this value here, we see when you add, it must be greater than 0. So what we see, all this stuff is greater than 0. So when it's greater than 0, always we know we get 2 unequal real roots. So we're gonna have to prove this, right? Let's prove it and see. So you're done already. In exam, if they ask you, you're done. But let's just prove for funny. You know, it's always good to prove funny. That's what we say. It's plus so prove. Okay, let's use a quadratic formula. Negative b plus or minus, and then b squared minus 4ac over 2a. So x equal to negative, what is a b? B equal to 18 plus or minus b squared. What is a b? B equals 8. A squared minus 4 times a. What is a? A equal to times c. C equal to negative 1. So over 2 times a equal to 2. So x equal negative 8 plus or minus. This is going to be 64. Excuse me, 64 is negative positive, so it's going to be plug this one. So it's going to be okay. Let me go slow. Say, hey, I was confused there. 64 minus, going to be, this is going to be negative 4 times this, negative 8 times negative 1, positive 8. Okay, that's going to be over 4. So our x we say equal to negative 8 plus or minus, and that's 72 over 4. So you see all this number meaning is b squared minus 4ac, b squared minus 4ac, but we see it's greater than 0 there. So we want to see the roots. What's going to happen to the roots? So x equal to negative 80 plus or minus, that's going to be 8.9 point something. 72 square root is somewhere the 8.5 or 48. Okay, 8.5. So this going to be 80.49 if you approximate. Okay, or 5. Okay. So divide by 4, divide by 4. So finally, we get x equal to negative 2 plus or minus, you divide that one by 2, you get 4.24. 4.24, yeah. This is going to be 4.24. So you see the face x is going to be negative 2, excuse me, negative 2. Sorry if I went so far that you could not see. So the face value of x, my apologies, sorry. Apologies, just in case you couldn't see. The face value of x equal to negative 2 plus 4.42. Okay, so which is okay, mean this is the face value of x. So either, I hope everybody can see that. If you cannot see, please let me know. Either negative 2 plus 4, which is going to give us positive 2.24, or when you minus, it's going to be negative 6.24. So you see, we got 2 unequal real roots. These are not imaginary roots, these are real roots. Okay, so what did you learn? We learned whenever b squared minus 4ac, mean this b squared minus 4ac, when it's greater than 0, we get 2 unequal real roots. We get 2 unequal real roots. Okay, That's it. We can check more example. That's so funny, but we're done right there, man. Let's go and check this one more example. So for example, somebody give you let's say x squared, and then let's say 3, let's say 8, yeah, minus x, and then plus 2 equal to 0. So let's taste face, okay, so let's taste, okay, how we taste b squared minus 4ac. What is a b? B is negative 1 squared minus 4. What is a? A equal to 80 and c equal to positive 2. So when you multiply this, you see, okay, this is going to be 1. Okay, 4 times 8, 32, 32 times 2, 64, minus 64. It's going to be negative 63. So we see negative 63 is less than 0. So we know this meaning is this one. So we see when you plug it in, you see all these values less than 0 because negative 63 is less than 0. And when it's less than 0, we say we get 2, we get 2 unequal imaginary roots. Done. So let's just prove. We can prove just for fun, but your question is done. So we say x equal to negative, what is a b? B negative 1 in the plus or minus in the quadratic equation. Negative 1 squared minus 4 times a. What is a? A equal to 8 here. And then times c. C equal to positive 2. Positive 2. Excuse me if you cannot see there. I hope everybody can see. If you cannot see, please say, Hamish, I can see. Do another video. I could do it for you. 2 times a equal to 8. I can do it for you, no problem. So this is going to be positive 1 plus or minus. Now let's go. 1 squared is 1 minus 4 times 8, 32, 32 times 4, 64. Okay, over 16. So now finally we got plus 1 or plus or minus, and this is going to be negative 63 square root over 16. So we say not, and put a small note here. If somebody give you a negative 63 square root, I can separate. I say square root of negative 1 and square root of 63. Excuse me, square root of negative 1 square root of 63, I can separate. And then we know square root of negative 1 equal to I or j, imaginary, and this one 63, we plug in the calculator, 63, or you can leave it how it is, no problem. 63, SD, you get 7.9, okay, 7.9, so it's going to be 7.9, but when you square root n numbers plus or minus. So finally, our x equal to 1 plus or minus 7.9 imaginary over 16. Do you understand what I'm saying? We say whenever square root negative 1 is imaginary, not real number. I'm going to write again here. If you square root negative 9 again, or negative any number, how are you going to say? You square it only. So you're going to say square root of negative 1 and square root of 9. When you square root 9, you get plus or minus 3. When you square root of negative 1 is imaginary. But if you plug in the calculator, it cannot give to you like normal calculator for lower grades, like normal grades. So you get 3i. A good example. So this is imaginary. Means whenever square root negative 1, we get imaginary. So we say okay. So finally, our x equal to 1 over 16 plus or minus 7.9 over 16 what? Imaginary. So we see we got two values of x. So we go 1 over 16 plus 1 over 16, we get 0.625. So 0.625 plus or minus, and then 7.9 divided by 16. Okay, we got 0.49, and this is going to be 0.49 imaginary. So we got two values of x here. X equal either x equal to 0.625 plus 0.49 imaginary, or x equal to 0.625 minus 0.49 imaginary. So what did you learn? We got two, but these are not equal because this is plus imaginary, 0.625 plus imaginary, and this 0.0 minus imaginary. So you can see that two not equal, but the imaginary answer. So that's why you have to say two unequal imaginary roots. That's why here we say two unequal imaginary roots. Two unequal imaginary roots. But it was just a proof by you only up there. So thank you very much for your time. If you have any question, just please let me know. Say, Hamish, I have this question. I don't say. You can leave a comment there. Whatever you want to comment. You can learn from me, or so you can learn my mistake. Thank you very much for your time. I appreciate it. Thank you.